PowerShell has some really nice features, such as the built-in jobs functionality. Jobs are useful if you have some code that you would like to run in the background while your script continues doing other work. For example, you can use jobs to get the event log from multiple computers concurrently. This is much faster than if you were to go sequentially, asking each computer for its event log, waiting for that computer to respond, send you its event log, and then moving on to the next one, because jobs allows you to do them all at the same time. In other programming languages, this is often referred to as threading. We're going to look at some basic jobs you can create using PowerShell. At its simplest level, start job can be run with the script block parameter, which you can embed any process that you wish to run. In our example, we've chosen to use getProcess. This will set up a job for us that will run the getProcess commandlet in the background. PowerShell will automatically assign a name for the job, but we should supply our own using the name parameter. This will make it much easier to receive our job once it's finished processing. We can find out the status of our job by using the getJob command and supplying the name that we previously assigned. In this case, you can see that our job PC1 is in the running state. Running this script again, we get some interesting output. We can see that there are two entries with ID 15 and one entry with ID 13. It is not obvious why we have two jobs with ID 15, but I believe it is due to the overhead of setting up the job and not giving it enough time to create the job properly yet. Perhaps more alarming is that they all have the same name as PC1. This is entirely valid for PowerShell, and you will need to take care in the script you develop to make sure that you're retrieving data from the correct job. To get some useful information out of the jobs we've created, we will need to run the getJob command and pipe its output to the receiveJob command. In this case, because we ran startJob previously supplying the name parameter of PC1, we've also run getJob supplying the name parameter of PC1, being mindful that we haven't duplicated that name somewhere along the way. To store the results for later use, we're simply going to assign them into a variable called results. For a simple example of how we can run multiple jobs at the same time, we have duplicated our code. We've still got the job named PC1, but we've also created a job named PC2. The script starts off by creating a job calling PC1 to get the system processes. It then runs a very similar job called PC2 to do the same thing. Your script has now created two jobs that will run in the background if you wish to complete other tasks before fetching the results. You may have noticed that we've piped the result of getJob to waitJob. WaitJob will ensure that the job we've created has finished processing before we retrieve any data. If you found this video useful, please leave a like and subscribe.